So chapter 1 is our transition into algebra. It's the first chapter that's in your textbook proper, and we're moving away from math with just numbers into math with numbers and letters. And so we're going to kick this one off. Each day this week I'm going to try and do a number of sections. These sections are a bit smaller, so we're going to try and do it sort of in this grouping, but there might be a little bit of a shift. But they should be shorter videos for each of these sections. So the first section that we're going to do here is about properties of real numbers. So real numbers are all numbers that exist on a number line. They are not imaginary numbers. Later on in this course, we're going to have examples of things that are real or imaginary. And so at this point, I wouldn't worry too much about that classification of real numbers just yet. Basically, they're the numbers that you can imagine. So these properties in math, when we have a property is something that is always true. And so it's a truth. And if it's a truth with numbers, it's also a truth with letters. When we have letters that are representing numbers in math, it's important to remember that what you can do with numbers, you can also do with letters. And so we're going to take some time with these. Oftentimes they're like almost obvious when it comes to numbers, but they do take a little bit of noticing when it comes to the letters. So the first one is the commutative property. And so if you think about what it means to commute, when you commute to work or commute to school, that means you're going to travel. You're going to move around, right? And so what the commutative property is, it's the commutative property of addition or multiplication. And it means that the numbers can move around and they still have the same value. And so here we have letters representing different numbers, and you can see that the A and the B added together, it doesn't matter what order they get added in, it's still going to be the same value. And so those would be equivalents, and that's what that equal sign means. And again, with this one, making something that you know to be true a little more confusing, 1 times 2 is the same as 2 times 1 if we go to the numbers. And here we're trying to conceptualize it with the letters. So the commutative property of addition or the commutative property of multiplication, I try and use those words as many times as I can, is a property, it's a truth. And so down here in these examples, it says fill in the blank to demonstrate your understanding of the commutative property. So what we're trying to do is not solve this. I'm not saying what is 9 plus 5. I'm saying demonstrate your understanding of the commutative property. So showing or illustrating the commutative property, I would fill in the other side of this with 5 plus 9. They've moved around, right? That's what the commutative property of addition is trying to say. Similarly, the commutative property of multiplication and demonstrating the commutative property of multiplication would have me switch the numbers around here. And so 8 times 2 is the same as 2 times 8. You can do the other two over here. I'm going to fill in my answers. And again, with these ones, I'm not asking you to solve them. I'm asking you to demonstrate your understanding of that property. So that's the first one, the commutative property of addition or multiplication. Order doesn't matter. The next property for us is the associative property. So again, if we think about these words, who you associate with is maybe your work associate. It's who you work with. It's who you hang out with, who you associate with. It's about grouping things. And so what we're saying here is that there is an associative property of addition or multiplication, and that it doesn't matter if you've got all addition or all multiplication in your examples here. It's saying it doesn't matter who hangs out with who, how these things are grouped, they're going to have the same value. And so down here, again, with the multiplication, it doesn't matter if you multiply these two and then multiply it by C, or if you multiply B and C and then multiply it by A. It doesn't matter how you group these. They have the same value. And so This one, it does say to prove it to yourself. So I am asking you to simplify this or solve it essentially. So I'd have to do what's in the brackets first because of order of operations. And so I'd have a 2 plus 11 or a 13 on this side. And on the other side, I'd have a 5 plus 8 or a 13. And what I'm trying to illustrate here is that, yeah, it does check out. It does match. Good old fractions in this one. So if I were to do this one as trying to illustrate the associative property of multiplication this time, I'm going to do what's in the brackets first. So 1/3 times 30 on this side. And if I do the math on that one, and you can flag me down in the comments or ask if I went too fast on this, we'd have 30 over 3 or 10 on this side. If I do it on the other side, I'd have 6 times 1/3 first, so it'd be 6 over 3 times 5, or that's really 2 times 5, and that's also 10. And again, with these ones, we were trying to prove it to ourselves. So this one again down here says to demonstrate your understanding of the associative property. So it can be the associative property of addition or the associative property of multiplication. And again, don't solve these, don't prove it, just illustrate your understanding. So with the associative property, it's how you group these things. So I can write down the exact same numbers, but this time I would group the 3 and the 4 together instead of the 4 and the 7 together. For B, if I'm illustrating the associative property, I group the 3 and the 4 together and then the 7. And down here, not solving it, just illustrating our understanding, we'd have 1/5 times 10 times 4 is exactly the same value. And this is a property that's true. It's easier to understand or conceptualize with numbers, but when we get into letters and algebra, these are also going to be properties that are true. So far we have the commutative, we have the associative, and they are either of addition or multiplication, both of these. When we flip the page, we are then going to do the distributive property. And the distributive property is one that you don't have the distributive property of addition and the distributive property of multiplication. You have those combined in one question. The other thing I wanted to mention with this, sorry, before I move on, is that there is no subtraction and there is no division. If we were to think about subtraction and division with the commutative property, order matters. 1 divided by 2 is a different value than 2 divided by 1. It really matters what's on one side. If someone is going to give you $500,000 or $2 million, that is a really different amount. And so in both of these, commutative and associative, it does not involve division or subtraction. So flipping the page here to distributive property, it involves addition and multiplication together. And so as the format in your textbook, this is like the pattern, if you will. We've got B and C added together, and then A is multiplied by them. And so what the distributive property does is says, okay, well, if we have order of operations, we would have to add B and C together first. But instead of that, we could also say, well, if A is multiplied by B and A is multiplied by C, that preserves the same value. So you might not buy it with the A's and B's and C's here. So let's try, let's practice distributing and then compare the answer if we were to follow order of operations or BEDMAS. So let's start with BEDMAS first, because that's something that we're more familiar with. So in order of operations, it would say do what's in the brackets first. So that would be 5 times 7 or 35, right? That's order of operations. Now, if we practice applying this pattern, if we practice a distributive property, I'm going to just rewrite it. Maybe that's not any neater. Now it says, okay, the 5 gets multiplied by the 3. So that's 5 times 3. And then the 5 gets multiplied by the 4. It gets passed around. Everything gets a chance. So it's 5 times 4. And so sometimes writing it out like this, if you remember this at all, this actually makes it look more confusing because you're more used to doing it in your head or partially on paper. So carrying on, I'd have 15 plus 20, right? Because multiplication would have to happen before addition. And again, I'd get 35. And the whole point of this is that those check out. Whether we do order of operations and BEDMAS, or we do the distributive property. We did it two different ways, and that's really, proving that this is the distributive property. It's true all the time. It's a true thing about math, whether it's letters or all numbers. Okay, so I want to kind of bust ahead a little bit here. The reason we are doing this is not for most of these examples here, right? The reason we're doing this is that sometimes we get down to ones like F, and F is really not yet in our abilities. But if we were to do order of operations with this one, we can't add B and C together. We can't add a banana and 2 carrots and tell you how many banana carrots you have. That's impossible. You can't do that. So in order to simplify this, we need to use distributive property. So I got ahead of myself, kind of giving you some context as to why we're doing this. These questions say, complete the following using the distributive property and then simplify. So demonstrate the distributive property and then simplify. So this one would have 4 times 6 plus 4 times 7. And so if I were to simplify this, I could do it the distributive property way, which is what I've launched into here. And you can always double check with order of operations. So 24 plus 28, and I'd get 52 on this one. All right, make silly mistakes. Okay, so there's a few more to do here. There's a whack of fractions for you to take a look at. Give those ones a minute to try. I'm going to throw the answers up here, and then in class, we'll do this a little more in showing our work. The fractions probably trip you up more than the distributive property, so it's a good review on this one. So you can pause it or charge ahead. Those are the answers. In class, we'll do them all out. Okay, so the last part of this 1.1 is really to kind of roll all three of these together. So as a quick review, we had the a commutative property of addition or multiplication. We had the associative property of addition or multiplication, and we had the distributive property. And distributive property involves both of those together. So as a quick recap, those are the three properties that we're playing with. In these ones, we're supposed to write an equivalent expression. So that is demonstrating our understanding of each of them. So this one says the commutative property of addition. If we were to demonstrate our understanding, it would be a 7 plus 3. This one says demonstrate the distributive property. Don't simplify it, don't solve it, just demonstrate the property. So that would be 2 times 3 plus 2 times 4. Demonstrating our understanding, not simplifying. This one says demonstrate the associative property of multiplication. And so the associative property is who you group with or who you hang out with. So same numbers, but a different grouping. So we put brackets around the 5 and the 3. The associative property of addition, again, same numbers, but grouped together differently. So the 5 and the 2 would have brackets around them. E is one that looks a little bit wacky. My cue here is that it's the distributive property, and this is like the reverse of everything we've done so far on this page. So the other half of this, writing the equivalent expression, would be 4 plus 5. It's harder to see in reverse, but I like that this one's in here because it does make you kind of think it backwards. Okay, and then the other column here gives you both sides of the equation and says, what is the property that's illustrated? And so for A, we've got them in different orders. So that would be the commutative. property of addition. B, I see brackets all over and it's all one operation. So it's not distributive property, it's the associative property. And this one, it's the associative property of multiplication. C, I see brackets again, but I do have a mix of operations. I have multiplication and addition. This one is the distributive property. And it's not like the other two where it's addition or multiplication, it's just the distributive property. D, nothing has changed but the order of these things. So that was them moving around or commuting, changing location. So that would be the commutative, such long words, bad writing too, property of multiplication. And the last one here is equivalent to this one, where it's the backwards version of the distributive property. So that does us for 1.1.